Hello everyone. So up till now you know that a function can call another function can call yet another function, and so on, right? And functions become the basis of modular programming in most of the programming languages. Now, have you ever encountered such a question that can a function call itself? Yes, it is very much possible in many programming languages. And when a function calls itself, this particular technique is basically called as recursion. So recursion is a technique that solves a problem by solving a smaller problem of the same type. So there's a large problem given to you, and if you can convert that large problem into smaller problems at each successive iteration, you can build a recursive function to solve that problem. So a recursive function is a function invoking itself either directly or indirectly. So what do you mean by indirectly? That there's a function called A, right? Function called A calls a function B, B calls A, right? That is an indirect recursion. And when function A calls itself, that becomes a direct recursion. Okay? So recursion can be used as an alternative to iteration. So up till now you have been writing so many number of programs using iterative techniques. Let's see recursion also. So let's see an example first, and then we'll see its bits and bytes. So you know that factorial n, it's a classical example taken in most of the books. So factorial n mathematically is defined as n into n minus 1 into n minus 2 up to so on. And you also know that 0 factorial is equals to 1. Okay. So what is the iterative program for getting the factorial of a number? So there's a return type of the function is integer, name of the function is factorial, and it takes a number whose factorial is to be found, and this particular piece of code can find the factorial of a number using iteration. Okay. So can we write a recursive definition to find the factorial of a number? So its recursive definition says something like this. You know that factorial n is equals to 1 if n is equal to 0. That is basically called as a base case. And factorial n is equals to n into factorial n minus 1 if n is greater than 0. So this is a recursive definition of factorial. And using this definition, can we write a program to solve the problem for us? So this becomes a recursive definition. So see, its return type is integer, name of the function, let's say I say it's fact, and int n. So if n is equal to 0, right, return 1, because the factorial of 0 is 1. Else return n into and call the same function again to find the factorial of n minus 1. Okay. So for first timers, it looks little bit complex to understand that what is happening behind the scenes. That that means when this function terminates, what gets supplemented here. So we'll see it successively. Now remember that this is just remember for the timing that this is just a factorial finding program using recursion. Okay. So a recursive functions, these are some criteria or some properties of a recursive function. A recursive function calls itself, right? Always. So this action is what makes the solution recursive, and you can see that a recursive function in our program is calling itself fact n minus 1. Similarly, second property is that each recursive call solves an identical, this is very important, identical but smaller problem. So initially I was intended to find the factorial of number called n. It got broken up into the problem size got reduced. Find the factorial of n minus 1. So it's again solving the same problem but smaller one. So a recursive function solves a problem by solving another problem that is identical in nature but smaller in size. Third property, a test for the base case enables the recursive calls to stop, and this base case should always be present. Otherwise, there is no means for the compiler to understand or to know that when to stop the recursion. So this becomes a base case. If n is equal to 0, return 1. So there must be a case of the problem which is known as a base case or the stopping case that is handled differently from other cases. And in the base case, the recursive calls stop and the problem is solved directly. So recursion, a factorial of 0 is 1. So if n is equal to 0, return 1. So this particular base case is solved directly. And the fourth property is, eventually one of the smaller problems must be the base case. It is not so that base case becomes altogether a different case. So the manner in which the size of the problem diminishes. So in every call, so initially I was intended to find the factorial of 5, for example. This 5 got reduced to 4, 3, 2, 1 and finally 0. And 0 became the base case. Okay. So the manner in which the size of the problem diminishes ensures that the base case is eventually reached. So base case is basically the same problem, but we can say it's the smallest sub problem which we can have. So in general, this is the nature of recursion. If stopping case, solve it, else reduce the problem using recursion. And if you can do it for any problem in general, then you can also write a recursive function in any programming language for that particular problem. Okay. So these are the 4 questions whenever a problem comes in front of you and you are asked a question that can you solve it using recursion? These are the 4 questions you must answer. How can you define the problem in terms of a smaller problem of the same type? Remember, it's not always possible to define the problem into its smaller constituents. Second, how does each recursive call diminish the size of the problem? So each recursive call must reduce the size of the problem as compared to its previous call. What instance of the problem can serve as the base case? The base case must always be present. Otherwise, there's no means of stopping the function calls. And finally, as the problem size diminishes, will you reach this base case? Because if you can never reach the base case as the problem size diminishes, there is no use of putting the base case. So if you have the answer of these 4 questions for any problem, you can write a recursive definition for that. Let me tell you one more thing. Think about in this recursive definition, if this base case is not present, right? First 3 lines are not present. It always says return n into fact n minus 1. So by now, your programming knowledge tells you very clearly that this is an infinite call. This becomes an infinite loop. Okay. And after some time, of course, the runtime environment will stop, giving you the error call stack overflow. Now, why does this gives you an error called stack overflow? For that, you need to basically understand that what is happening behind the scenes when you solve a particular problem using recursion. Okay. So with this, thank you very much for today. Do some simple problems using recursion, and then of course in some other lecture we'll see that what happens behind the scenes and how does a compiler solves recursive functions. Thank you very much.